slotted Aloha protocol, what was the improvement when you compare to pure Aloha protocol is, so the when you get the data, the moment when you get the data, it is not possible for you to transmit the data. So what you are supposed to do it, you need to wait for the time slot, that is the entire time duration of data transmission has been divided into slot. So if you have the data prior the data slot has been started, so the moment the data slot started, you can able to transmit the data. So means what, before we go for data transmission, there was a systematic way of arranging the, or there is a systematic way of dividing the data channel into fixed number of time slots. So the moment time slots initiated, you can able to transfer the data. So by the use of this slotted Aloha protocol, what was the advantage is that, so only in that corresponding time slot, if two or more stations are transmitting means, then the collision was possible. Okay, so that was the things what we call it as a slotted Aloha protocol. Next, what we come up with one more type of multiple access scheme, that is called a carrier sense multiple access scheme. So in carrier sense multiple access scheme, we have studied three important protocols. One is called as a one we called it as a carrier sense multiple access. One more is called as a carrier sense multiple access collision detection, and one more is called as a carrier sense multiple access collision avoidance. So these are the three important protocols what we have studied in the carrier sense multiple access. So along with this, there is one more type of accessing the channel, and this accessing the channel methodology we are going to call it as a controlled access. Okay, so in controlled access, what we can do is, so there are three important technology or three important methodology are there in controlled access mechanism. So one we are going to call it as a reservation, second we are going to call it as a polling, and the third one we are going to call it as a token passing. Okay, so means what, here there will be no any contention in order to access the channel. So rather than what we will be having is, we will reserve time slots, or we will reserve some frequency component, or we will reserve some time slots, so that the station who is having the data, so in the reserved time slot only they can able to transmit the data. So by reserving the time slot, or by reserving the duration in which time the station can transmit the data, so through use of this reservation or through the use of controlled accessing the channel, we can able to minimize the collision happening between the one station to another station. Okay, so among that, in the controlled access methodology, so what we are doing is, the first method we are going to call it as a reservation method. So in the reservation method, what we do is, so before the data has been transmitted by the station, so what it has to do is, it has to make a reservation for data sending. Okay, so before it transmit or before it gets the data, okay, I got the data from the network layer. Now what I want to do is, I want to transmit the data over the channel. So directly you cannot able to transmit the data. So what you are supposed to do is, you need to reserve your time slot. So once you get a reserved time slot, in that time slot only you can able to transmit the data. So that is why the name is called as a reservation. Okay, so now you can see here, if you have a n number of stations, let's say if you have a five stations in order to in the network. So now what you are going to do is, the available time of data transmission, it has been divided into five number of reserved mini slots. Okay, so in the reserved mini slots, whenever the station want to transmit the data, so first it will reserve its data transmission in a particular mini slots. Okay, so once the mini slot or once the reservation will be get to the station, now the station what they can do is, they can actually transmit the data based upon the time slots what it has been allocated. So you can see here in the given diagram, so we have five stations, and these we have five stations we have, and five mini slots has been created for each stations. So whenever the station will be reserved, so based upon the reservation which is given by the station, so based upon that we can able to transmit the data. So you can see here in the direction of the packet movement, so you can see in the reservation frame. So in the reservation frame, you can see for the frame number one, we have allocated. So therefore, the data from the station one. Therefore, the data from the station one can able to transmit the data. You can see the data station one. So you can see the arrow mark is, so in the time slot of one, that is this is the time slot which has been allocated for the station one. So in the station one, so we have made it as one. So one means it indicates that, okay, so the time slots will belongs to the station number 1. Okay. So now what happens is, you can see here in the next reservation time slots, you can see station 1, station 3 and station 4. So they all are corresponding to 1. So means they have reserved the time slots. So therefore station 1, station 3 and station 4 data we have. Okay. So like this we can have a controlled access of the channel when you want to transmit the data. Is that clear for this? So the next one is, we are going to call it as a polling. So what you mean by generally polling? Polling is nothing but activation. Okay. So whenever some station has to transmit the data, so it will transmit the data based upon the initiations which has been given from the some controller. Okay. So in this case, in polling system, we are going to call it as a two types of stations we have. One type of station we are going to call it as a primary station, and one more type of station we are going to call it as a secondary station. Okay. So the primary station, what it does is, it will act like a coordinator or it will act like a controller, whereas the secondary stations we call it as a devices. Okay. So now what happens is, whenever the data has to be transmitted, then the data transmission will be initiated by the primary device itself. Okay. So now you can see here, whenever some device wants to transmit the data, so it cannot initiate the data transmission. Instead of that, what has to do is, the primary station has to initiate the data. So how it will initiate the data is, so it will send an acknowledgement. Okay, it will send and select signal. So what it will send as a select signal is, so whether you have any data, so whether you have any data. So yes, I have a data. Select means selection of the stations, it will be checked. Whether you have any data, yes, I have a data. So means what? The station, the secondary device will send an acknowledgement saying that yes, I have a data. Please provide me an access to transfer the data. So what it will do is, it will transmit the data to the secondary device, and then after transmitting the device, the secondary device, what it will does is, it will send an acknowledgement. Okay. So this is how the polling will work. So now you can see here in the right part of the diagram. So you can see here, when the primary device, it has polled for the station 2 whether you want to access the data or you want to have a data to be transmitted, means since the station A does not have any data to transmit to the primary device or some other data, so what it has done is, so it has sent a negative acknowledgement. So negative acknowledgement indicates that the station A does not have any data to transmit it to some other station. Whereas in the case of B station, you can see here, the primary device, it has polled or it has initiated to transmit the data for station B. Now the station B, what it is saying, yes, I have a data, I want to transmit the data. So what it will does is, it has transmitted the data to primary device. So the primary device has to get acknowledgement to the secondary device, right? So therefore it is giving an acknowledgement. It is giving an acknowledgement to the primary device, secondary device, saying that yes, I have received the data and I will be giving an acknowledgement. So means what? Whenever a data, it has to be transmitted to any secondary device, so the secondary device, what it does is, it will transmit the data to primary device, and the primary device will have a responsibility to transmit to the corresponding secondary device. So how it will does is, so if it has the data to be transmitted, it will periodically send some polling signals. So the station which will respond the polling signal, they will get a chance to transmit the data to the primary devices. So the secondary devices will transfer the data to primary devices, and the primary devices will get an acknowledgement to transmit the data to secondary devices. So this is last one is, we are going to call it as a token passing. Okay, so the last one we are going to call it as a token passing. So what you mean by token passing is, so whenever any station wants to have a data to be transmitted, so it will have a tokens. So tokens is nothing but, it is a special packet. Okay, so through the use of these special packets, the station will get an access to transmit the data. And one more thing you need to remember is that in token passing method, all the stations will be connected in a logical ring fashion. All the stations will be connected in a logical ring fashion, and the station which is next to it, we are going to call it as a successor, and the station before to it we are going to call it as a predecessor. Okay, so now in token passing what we do is whenever a station wants to transmit the data, it will generate a token. What is that token? Token is nothing but it is a special packet. Okay, so that special packet, it will have some information. So what information is, it will requesting for the channel to transmit the data over the ring, and it will be having who is the sender and who is the destination to which station that has to be received. So all this information will be embedded in a special packet called as a token. So the station which receives this token, they will see that okay, so this is the sending station what the data wants to be transmitted, and this is the destination stations where the data has to be routed. So it will check it out. So if that token is belongs to means, it will receive that token and it will send an acknowledgement to sending station. Okay, after receiving an acknowledgement from the receiving station, the station A, what it does is it will send the data. So by using this special packets called as a token, we will each station will get an access to access the channel. Okay, so depending upon the token which has been received by the station, so those stations will transmit the data to the preceder and successor. Okay, so if the data has to be forwarded in a forward direction or in a right direction means, then the data will be forwarded to the successor, or else if the data has to be reverse or it has to be go in the reverse direction means, then the data has to go through the predecessor mechanism. Okay, so this is how the token passing methodology will work in the case of reserved access mechanism. Okay, so you can see here in the diagram the logical ring and physical topology in token passing access method. You can see here. So the first one we are going to call it as a physical ring. So you can see all the stations are logically or physically connected in the form of ring. All the stations are physically connected in the form of ring. Okay, so means, and here you can see here in this ring, means its physical ring means it is not directly by connecting the wires, they are not connected, so they are logically connected in some different manner. Okay, so the first one we are going to call it as a unidirectional logical ring. So the second one we are going to call it as a dual ring. So dual ring means in dual ring what happens is the station can simultaneously transmit the data and simultaneously receive the data. So such a logical ring we are going to call it as a dual ring. So you can see in this third case, it is a bus ring. So in the bus ring what? So all the stations are connected to one common coaxial cable. So that coaxial cable we are going to call it as a bus. So in this case, whenever a station wants to transmit the data, so the data will be forwarded to all the stations. So depending upon the destination stations to which the data has to be circulated, so based upon that, the packet will be routed within the network. Okay, and the last one is we are going to call it as a star ring. So in the star ring, you can see all the stations are connected to one controlling access devices that we are going to call it as a controller or an access controller we are going to call it as. So through the use of this access controller, each stations can able to transmit the data to the subsequent station through the preservation or under the control of the controller, or we are going to call it as an access controller. Okay, so this is how it will work in the case of controlled access mechanism or reservation based channel access mechanism. Is that clear? This one, TCP protocol, whether it is a OSI protocol or whether it is a ring topology or whether it is a unilink suplex mode of communication, duplex mode and a half duplex mode of communication. So read the question properly and based upon that you need to write. And Shreya has submitted the assignment. Yes, Shreya, I have received the assignment. I can able to see the assignments. Okay, thank you.